Okay, we're going to finish up the practice quiz number 6. We're going to finish up the multiple choice. Looking at number 5, it says that the second derivative of a function is given by x minus 2 squared times x plus 3. Which of the following conclusions can be made? All right, if you already have the second derivative, you need to find its critical points by setting the derivative equal to 0, the second derivative. So critical point here would be x equals 2. Critical point here would be x equals negative 3. I'm going to do a sign diagram at negative 3 and 2 with my critical points for the second derivative. These are possible points of inflection. That's what we gain from the second derivative. And our sign diagram will tell us concavity. Choosing test points to plug into the second derivative, I'm going to choose these points to test. So plugging in negative 4, I get a positive times a negative, which is a negative. Plugging in 0, I get a positive times a positive, which is a positive. And then plugging in 3, I get a positive times a positive, which is a positive. Okay, so I'm going to look at the 3 choices and see which ones are true. F of x, which is the original function, pay attention to your notation, is concave up on the intervals from negative 3 to 2 and 2 to infinity. That's true. They are concave up here and here. So number 1 is true. F of x has a point of inflection at x equals negative 3. In order to have a point of inflection at x equals negative 3, there needs to be a change in concavity, and there is. It's concave down, and then it switches to concave up. So this is a true statement. The last one says that the derivative will have a relative maximum at negative 3. So let's go back to our sign diagram of the second derivative. Does it have a relative maximum on the graph before this one? So remember, your sign diagram can also tell you what's happening on the graph right before it, which would be the first derivative. And since it goes from negative to positive, the graph before it would have a minimum, not a maximum. So number 3 is incorrect. So A, 1 and 2 only would be the right answer. If we're looking at number 6, we are given an original function, and we want to find k if its horizontal tangent is at x equals 4. If you see the words horizontal tangent, that's when the derivative is equal to 0. And they're telling us that the derivative at 4 will be 0 because it's a horizontal tangent. So I need to find the derivative of g of x. So I'm going to take the derivative of g of x, which is going to be 3k x to the 1/2 plus, and taking the derivative of this, 2x natural log of x is product rule. Derivative of the first times the second plus the first, oops, that should be an x, sorry, times the derivative of the second. Derivative of natural logs 1 over x. So if I were to simplify this down, this is what I would have. Because x times 1 over x, they cancel out, leaving me with just 2. I'm going to set it equal to 0, but I'm also going to plug in 4 for x so that I only have one unknown, and that is k. So this would be 3 times k square root of 4 plus 2 natural log of 4 plus 2. Okay, so this square root of 4 is 2. 2 times 3 is 6. So this would be 6k. And I'm going to bring these two to the other side because I'm trying to solve for k. And then I'm going to divide both sides by 6. So now I have k is equal to, and if I reduce these, that's going to be negative natural log of 4 minus 1 over 3. I took a 2 out of each coefficient. Now, this is actually the same answer as C because I'm just factoring out a negative 1. So if I pull the negative out front, it would look like this. And that negative is supposed to be right in front of the fraction. Excuse me, that should be a 3. Okay? Now, last question, number 7. Find the total number of relative minimums of the function f of x whose derivative for all x is given by this. So here is the derivative already in factored form for you. So if you want to know minimums from the derivative, you need to do a sign diagram. So my critical points are 0, 3, and negative 1. So putting those on a number line, I'm choosing test points, so this would be negative 2, negative 1/2, 1, and 4. And I'm plugging all of those into the first derivative. Plugging in negative 2, I get a negative times a positive is a positive. Negative 1/2, negative times a positive is a positive. Plugging in 1, positive times a positive is a negative. And then plugging in 4, positive, positive, positive. All of it's going to be positive. So, what are the total number of relative minimums? Remember, a minimum occurs on a first derivative sign diagram when it changes from decreasing to increasing. So here would be my minimum. So it's decreasing and then increasing. So I'd get a minimum out of this. So I have a minimum at 3, but notice A is not my answer. The question says, what is the total number of relative minimums? There's only 1. I will put the free response on in the next video.